In this lesson, I would like to cover loop and arrays, which are the bread and butter of cables. As we saw previously, we saw array as a data type, but we didn't really have time to practice with them. So in this lesson, I would like to start really going a bit deeper and to create shapes that we are going to animate using our arrays. So as always, I will start with the trusty main loop. We know that we're gonna draw some shapes, so I'm also gonna put down an orbit control so I can move around with my camera. I know that many things are gonna happen, so I'm gonna put a sequence as a way to control the flow of operations, as we saw in the previous lesson. And we'll start by, as always, by drawing a simple cube. So I can put a Lambert material and a cube down. All right, so we have the base setup to get started with arrays. So having an array would mean that we would put all the positions of our cube into one array and draw everything at once. Unfortunately, what I see in most cases is that people use a repeat operator, so a way to basically execute everything that is below to draw many shapes, many of the same shape at once. So this is a mistake, and I'll demonstrate so you don't make the same one. So to repeat something, repeat is very handy. You put the repeat up, and it's just simply a way of re-executing everything that is connected to the yellow cables. For one input trigger, you repeat below as many times as this number here. So let's say I want to repeat my cube 3 times. I'm going to connect the repeat, and it seems that nothing is happening. So don't worry, we always have the F key to see the flow mode, and we see that the cable here seems to flow faster than the one before. So it's actually repeating. The problem is we are drawing the 3 cubes at exactly the same position. So to actually see them, we could put a transform, but if I'm transforming the value here, I'm also moving the 3 cubes at the same position. So what I would like to do is to use the second output of the repeat, which gives me the index. So basically at which iteration of the loop we are. And this index doesn't move for performance reason in the UI, but it's actually counting from 0, 1, and 2. So if I'm just connecting this index to my X position, I will be repeating the cube 3 times. But because the cube is exactly 1 unit, they are all touching each other, so it seems that it's one big cube. But if I reduce the width here, we actually start to see 3 individual cubes. So this repeat is counting from 0, 1, 2, 0, 1, 2. Forward, so it's counting from 0 to the maximum value. Backwards would be, it starts at 3 and at 3, 2, 1, for instance. So in most cases, you would use the forward operator, like 99% of the case, from 0 to 2 in our case. Okay, so that's one solution. It works fine for 3 cubes. But let's actually measure. Let's see the performance, how it changes according to how many iterations we have in the repeat loop. To measure performance, there's a handy op we can put called performance. And it will basically create this a bit like numbers that you see when you click it. You can open to inspect and see more details. But what's important here is mostly the frame rate. So remember, to be smooth on the web, it needs to be at least 60 FPS, and if your screen supports more. And we have like how many times the code takes on your CPU and on your graphics card. So let me disable the flow mode so we have a bit more performance. I'm saving and I'm repeating. 3 cubes, 10 cubes, nothing happens. 1,000 cubes, 100 cubes, nothing happens. Now 1,000 cubes. See, my CPU starts to already jump, but it's okay. Now 10,000 cubes, and it's dead already, right? It's very laggy. It's 14, 12 FPS, and I have a good computer, so probably maybe with yours you will not be able to reach 10,000 before it breaks down. And 10,000 cubes, it's not a lot. It seems like a lot, of course, but like remember that this is for the whole patch, the performance. So we are only simply drawing really basic, ugly cubes. We have nothing else. So if we start to add animation, UI, interactions, or whatever, the whole performance will be degraded the more ops you have in the patch. So if you're already at the limit with 10,000 cubes, it's not gonna do it. So this is not the way forward. Don't use the repeat to draw many of the same shapes like this. However, repeat as an op is very, very handy because it doesn't actually, it's not even tied to graphics. It's just a way to repeat triggers, basically. So, for instance, we could use the repeat to create an array, basically programmatically. So, remember before we had this array. I showed this. We have this array generator and we have this length 10, and we say, we are repeating the value 10 times, and I can put here a this array table. So let's say I want to bind the number of repeat to the length of the array, right? I'm gonna drag this number and I'm gonna connect it to here, maybe 10 values, and connect this. So they both are linked, right? If I move this number, both are changing. Now, with this number here, I can count from 0 to 9, so 10 values starting from 0. I can also normalize the value. So it's the same thing, but you divide by the maximum length. So you have a value between 0 and 1, very handy. But what if you wanted to do something a bit more fancy? For instance, I want to offset all values by 3. So I want to count between 0 and 9, but I want to add 3. So basically, I want to count from 3 to 10. So, okay, all the ops that we have with regular numbers, we have them with arrays. So I can do array sum, for instance. And I'm going to connect this here. And I'm going to say, okay, I'm going to add 3. So I'm counting 3. So I'm adding 3 to each of the values here, right? This is okay. I can also, let's say now here, multiply, right? After, why not? So array multiply. So you already start to see that I'm basically creating values that I maybe use as position for my cubes. So this is all good. There is a problem about this though, is that for each array operation that I put in this chain, I'm basically recomputing, iterating over all the array. And you can see that by if I print the array table at each step. I have this array from 0 to 9. Then I'm adding a value. Then I'm multiplying. So I went over the 10 values 3 times. 1, 2, 3. Doesn't seem like a lot. Computers are very fast, for sure. But if you start to put 10,000, 100,000 shapes, and you have many complex, not individually complex, but you have a complex chain of operation, you start to lose a lot of performance because you are reiterating over all the values for each operator. So the cool thing would be to be able to do all the complex chain of operation and just one go and work at the unit level, at the number level, instead of working with arrays like this. So the way to do this, it's actually, at the time I'm shooting this video, it's actually pretty new. It's called comp for compose array. So you have comp array, comp object, but let's just focus for now on comp array. And so how does it work? It's the same technique basically. It's very cables-like. You need to, you put it in the chain, and everything that is, all the operators that it starts with comp, so with comp array in our case, that are put below will add to this output array here on top. So let me just start simply without the repeat. I'm connect this comp array, and then I'm gonna put a comp array push number because I just want to add the number in this array. So I'm pushing 0, and then I can actually view my array here, which is a single value of 0. If I want to add another value after my 0, I can comp push array, connect it next, and then I'm saying I'm gonna add 1. Right? So I could redo. I'm not gonna copy and paste 9 times, more like 10 times to get this array that we basically have generated in one up here, but I can reuse the repeat though to repeat as many times and fill this array programmatically. So let me demonstrate that. I'm pushing this aside. I'm using this comp array. I'm saying, oh, okay, I'm gonna repeat 10 times. All the index, at each index, basically, I'm gonna push it through the array. And if why we only see the last value? Because it needs to be basically put on the same cable, on the same flow here, just only one comp array, so I'm gonna push only one value. But now if I disconnect this guy here, and I'm putting the comp array there, and then I'm putting everything below, now I have my 10 values, right? So this is it is one more up than having this. But now if I want to make the sum here, I can just add, pressing the plus sign, right? I'm adding 3, and then I'm multiplying by 2.3. So I go here, I press the star key, and I'm multiplying by 2.3. And now I have the same array, but I only went and iterated over the array once. So this is much more optimized, this flow here, compared to playing around with array something operation. But we have a lot of them, right? If you just type array, you have 284 at the time operator that start with arrays, right? So not all of them are here to generate or modify the array, right? But if you want to apply a power function, you could now with the comp array workflow do this much more efficiently, right? So when you need to generate and create stuff, right, think of this comp array. So now, okay, let's say that we have our could be our x values for our cubes. But for position, remember when you have the transform, we have x. If we just want to move the position, we have x, y, and z and z here. So this is only one of the values. Let's mix both. Let's make both technique, comp array and this array 1, 2, 3, 4. So let's imagine that this is we're gonna call this one position x. And here we're gonna call this position y, and we need at least for now position here z. I don't need the repeat here. Position z, and let's say that we want at the beginning only we don't want to push the cubes back and forth, so we can just set this to 0. So now I have 3 arrays. To set the position for each of my cubes. What ops could we use to make it efficient, as I said before? The op we are looking for is called mesh instancer. Mesh instancer. This one is very, very handy, and you will see it all around in cables. It's really used everywhere. So I'm going to connect. 2 things you need. Of course, you need to trigger it to be able to see something on the screen. And you have also this second input, which is the geometry. Which shape do you want to repeat? So for now, we say, hey, we want to use the cube that we have here. So if you notice, we have this cube. So, okay, we need to trigger this cube. And what we are looking for is not to render the cube here as an individual cube, it's just to get to the second output and check the geometry. So basically we can inspect if you're not sure what's in your cube or any basic shape in cables. You can have this op called geometry info, and it will tell you, okay, this cube is actually 12 faces, indices, vertices, normals. So it's how many triangles, the position of each individual triangle, and also the normals, so that the material can calculate how the light should reflect on the shape, basically. And we have this for all basic shapes. You try this with sphere and see how, for instance, if you change the number of a triangle in the sphere, how to make it very round, you see how big the numbers are to really create a smooth surface. Don't forget that everything is a triangle on the GPU, so it's always a combination of triangles to make anything that appears, even if it's very smooth. So this is just to explain what's in this geometry object here. But this object, we need to connect it to the mesh instancer. And now this cube here is not drawn by the cube operator, it's just drawn by the default mesh instancer. So just to show you that it works, at the beginning it only draws one thing. Now, you have many inputs in the mesh instancer. The most important ones are here: position, scale, and rotation, and colors. And notice that, okay, the type of position is called array3. What is array3? We know arrays, we've covered them here and before, but it's what is an array3? So to optimize thing, WebGL asks us to flatten, to have an array that is basically a combination of all the position put triplet per triplet. So let me demonstrate this very simply. Let's say that I'm taking all this position. I'm going to comment it out. Up. So let's call this array position. So what Cables, but what WebGL wants is something like this. Position of my first cube, we'll call this x0, the y position of my first cube, and the z position of my first cube. Then if you have another cube, you have to put after that the x position of my second cube, y position, and z position of my second cube, and so forth. So it needs a flat array of triplets. The triplets here, it's if you want to have a triplet or a group of 2 or tuple or 4 or 10, this is called the stride of an array. So let's say we want an array of stride 3, so that the 3 things here are grouped, let me zoom here, up, together. But to be more optimized, it's not an array of 3 values, it just wants everything to be flat. So it's just an array combined like this. And so how do we create this? Because here we have 3 individual arrays, x, y, and z, but we need to basically weave them together, to pack them, to make an array 3. So let me show you this op called array pack. And it says pack 3 individual arrays into an XYZ array. So if you have array pack 3, you have array pack 2 and array pack 4, which are basically all the dimensions that we could use in cables. So this there's an optimization, so it needs to be connected to the mesh instancer, so that if these arrays are not changing each frame, then they are not being basically recombined together. So it only combines them when they're changing. And what I need now is 3 values, 3 arrays, x, y, and z. Now I'm putting this and I'm viewing my table. And so Cables has an annotation for the UI here, the visualization, that knows that, if you expect an array 3, when I make the array vs table, I can group x, y, and z, x, y, z in each line like this. So it's pretty handy to try to debug, because otherwise you would see everything like this, right? X, Y, Z. So it is not very handy to debug, basically. So this is pretty handy. We have packed our array, and now we can actually pass it through the positions. So I have my positions. I'm gonna reset my camera, and notice that I'm not really in the frame, right? So what I could do is start to, because I've all start to move the values everywhere. So let's say I'm adding 0 and I'm multiplying by 1, right? So at first I'm trying to put everything back to normal. So this is my 0, 0, but then my Y position is counting up. So what I could do is I could start to, as we maybe saw before, make a transform view to move my camera. So by default, I'm already, a bit further away from the action. So I'm going here, moving my position a bit back. Okay. But it would be nice if everything was also centered. So first, maybe let's put a material, because it looks really ugly. So this we know, Lambert material. Right, I have, white cubes. Now, if I have more cubes now, before centering them, so I'm unzooming with my mouse, and you see, okay, we have my 10 cubes that are being put. And just to show you the performance of this, let's now crank up the repeat value. I have 10, I have 100, 1,000, 10,000, 100,000. And if you do this, you see that it breaks down because I'm using I think the visualization. If I remove this, because if you have many values, you should not put the vis array table. So let me cut this everywhere. So it breaks down because I'm using two things. I'm using the vis array, so that means that in the UI I'm really like outputting 10,000 values, so I need to disconnect this. But also look at this branch here. I'm repeating at each frame. I'm recreating the 10,000 or 100,000 values for my array, but this array doesn't change. I don't need to repeat it. So when you create comp arrays and repeat, you also need to make sure that if it's not moving, you need to trigger this only once. So if I'm triggering only once, then I'm changing my positions. So if I repeat this, let's say 1,000 times, and then I'm triggering this again. Now, okay, this branch has been triggered only once. I have my 10,000 values, 10,000 values here, and I'm packing everything. And now I'm drawing this in my mesh instancer. And notice that doesn't really sweat. Like the computer doesn't really care about the number of values. If I want to put it higher, then I will need to re-trigger this once. So now we can also ditch the other things. It's a bit weird. I'm trying to combine both techniques to show you that it's equivalent doing a repeat and a comp array, or using the pre-generated values here and packing them. But do we actually need to pack them if we use the comp array? Do you agree that we could also remove the array pack and weave the X, Y, and Z value directly in and create the final array here as position, and then passing it here to the mesh instancer? And I will basically skip the use of this op. So it's a bit more performant, and it will also actually be a bit clearer in the patch. So let me demonstrate. I'm going to destroy this op, deleting it, and I'm going to only use the comp array to create. Now, instead of position X, I want to do position X, Y, and Z all together, because it's going to be put in the same array. The repeat is the same, right? I don't need to, that's the whole point. Now what I could do is to create a sequence here and start to say, okay, this is going to be X. Now I can have count push number for Y and the same for Z. So I'm doing a sequence, but I could technically put them one after the other, right? Now we are very good with control flow, so we know it's exactly the same. Just for clarity, I'm doing this. X, Y, and Z. Okay, so I know that for now, this position is also counting. So I'm gonna use the same repeat here and there, and position Z is 0. So now in my array, if I go back to a very small number here, right? So I'm deleting this completely, and I'm going for a small number, 10. And now I can view my array. And if I trigger it again, now I have X, Y, and Z. So this doesn't know that's an array 3. So you see the visualization is not reacting, but I have 10 repeat, and the final size of my array is 30. So it's good. I've really pushed 3 values per iteration of my loop here. So now I can really crank up the value here, and I can say, hey, if this guy repeats, change the value, then re-trigger this, right? So there's an op called trigger on number change, on change number, right? So if I manually by hand trigger this, I also get for free trigger here, the next trigger. So I can say, okay, repeat, connect this to the number of iterations, but also connect this here. So if I move this value here, the repeat should happen again. And of course it's not connected. So I need to now get the output of this and connect it here to my positions. So this is actually quite optimized because this is only being run once. If I want to change the number of repeats, it's fine. It's being regenerated. So, and you notice that I don't need now the array pack. I showed you it because it's like I would say the old way, but it's all throughout the cables examples you would see that because this is pretty new. But this is really much more optimized. And I think in my view also simpler. So with this, we can create our machine center and have our position. Now, what if we wanted to now compute check the performance? Going back again, 10, 100, 1,000, 10,000, 100,000, no problem. I have a good computer, right? Let's try to push 1 million, 1 million. So here, yeah, it starts to draw. I mean, 1 million, this starts to be a lot. But imagine here I've drawn 1 million cubes. So it's more than enough, I think, for all our projects. You would never use 1 million objects, especially if you want to have more, right, in your patch, animations, interactions, colors. But I think 10 or 100,000 is already a good number that you could use, for instance, for particles. So let's going back to 10,000. Now, something that we could do is to, I mean, instead of having all the cubes going upwards, what if we put them, in a kind of a wave pattern? Maybe you remember your middle school math about the sine wave. So the sine wave is a function that takes any input. It's basically a rotation around the circle. It's not a rotation, but it's a function that is bounded between -1 and 1 that is very smooth and periodic. So I can put the sine wave here and say for each value, instead of incrementing all my values, they go through a sine wave. So once again, I have to, here, because it only triggers on repeat, I can also, maybe you didn't see that, I add another op called the trigger button, so I can manually, if I want, trigger it. Okay, if you don't want for now, because we are basically composing, right? We don't really know what we are looking for. I can also just ditch the trigger one, so I can shake it around and be aware that I don't want to put too many repeats though, because it's gonna be laggy otherwise. But let's say I'm starting with 100 values, right? So I can start to iterate. So if I go back to my sine wave and I change, for instance, the amplitude, I make the squares, more or less separated. If I change the frequency, I would create more or less waves, right? And notice that I can start also to animate this. So I could use a timer to move all the position like this. So that, I mean, sine wave is the base of all animation and graphics mostly. So we'll have more example of using sine waves, but just the possibilities are really endless here. Something that we can also play with is the phase, which is basically would tell you like what is the offset, like where does it start to draw the wave, on the bottom or at the peaks or trough. So I can move that as well. And notice that I'm not changing the amplitude nor the number of waves, nor I'm just moving where they start. But if I animate this, I start to make cool animation. So I could put, for instance, use, as we saw before, a timer, or using the triggers from the main loop to create numbers to animate this. But just to quickly demonstrate this, let me put the timer and connect the timer to the sine wave, to the phase. And now I can speed it up and have some counting wave like that. Of course, now that I'm editing at each frame, basically, or each tick, the Y value, then the array cannot be cached, right? It cannot be computed only once, because you're basically asking the computer to change the number all the time. So by doing this, we cannot go as high as before with the number of shapes. We cannot have 1 million or 100,000 shapes moving, because this really is executed on the CPU. And to be very optimized, we need to have this kind of animation on the GPU. It's a bit more advanced, so it's not going to be covered in the course, not on this course here. But I mean, come on, it's already plenty enough to have cool animations. So Now, something that we could, if you go back to our mesh instancer, we have the material, right? We can put everything red, but what if I want to color individually like all the cubes? I don't want to have the same color. So that's what we have in other parameters. So we have the scale. We can scale each individual cube, rotate cubes. So let's say I want to, before going to the colors, I just quickly want to scale and rotate just to see the potential, because before we had the transform, right? We have position, rotation, and scale is, you can actually split it in scale X, Y, and Z. So here I don't want to change. I can directly create an array of numbers, and that will basically represent for instance, the scale and all the rotation. I need to match this number, needs to match with the number of repeats, the number of instances that we have. So I can put this here and connect to the first input and say, okay, if I want to scale or rotate, it's always an array 3. So I need to put the stride to 1, 2, and 3. So it's called ABC. And then I can define how I want the scales, like what is the range? A scale cannot be 0 or negative. So let's say between 1 and 2, 1 and 2, 1 and 2. Then this array is an array 3, and I'm connecting here to the scale array. So you see now cubes are individually scaled. Another thing we could do, notice that we are also, it's a bit weird because we are redrawing the cube to get this basic geometry at each frame, but we don't need this because we're gonna move the scale and scale the cube with the scale array. So this geometry needs to be uploaded to the GPU only once. So this, we can also put this small optimization. It's small things, but when you add them up together, it really creates the big difference in the end. The goal is not to pre-optimize things. You need to be happy with your design and then start to drill down on performance. But if you have obvious optimization that you already know you can do, then do them right away, right? So here, okay, I've moved my scale. You know, if I put 10 to 3, then of course they're going to be bigger, but it could be below, right? It could be 0.1, right? And you have very thin cubes, and we can put this everywhere. And if I'm not happy with this distribution, I can just move the seed and, you know, ask for another, for instance. I could use the same op, but this time to generate random colors. And we know that colors are not an array 3, they are an array 4, because we have R, G, and B, and alpha value, which basically accounts for the transparency. So I'm saying, okay, I want to A, B, C, D, and I know, because we remember the clear color, that values needs to be bounded between 0 and 1, because we are not in HDR mode. And alpha, here I want to keep everything opaque. So here I'm generating basically an array of stride 4, and I'm connecting this array to my colors. But we have to be aware this array is not connected to the right size. So I also I can go back to my repeats, but I can also, all the ops array, they also give back again the number of elements here. So I can connect it here to optimize things. So now everything is procedural. If I change here the number of repeats and I put, 10, it reacts, 100, it reacts, and so forth. Pretty cool. Now, something that bothers me a bit is that our camera is always centered in 0, 0, right? It's which by design, which is here. But now we have drawn 100 shapes to the right. So how would you go about making sure that we are always centered, so that irrelevant of the number of numbers that we draw, I'm always seeing the pattern at the central position? So think about it. Okay, so what I would do is that, okay, we have moved the camera backwards, so that is good, but what we could do is now move all the position of the cubes, to the left, basically, by finding the middle point of our shape and making sure that we are always subtracting the middle point to the left, so that we are always basically centered. We're not moving the camera here, the camera will always be at 0, but we are drawing the shape more to the left, if you will. And this is pretty easy to do because this is where we draw our X thing, right? So we'll have to do something with this coordinate. if I have 10 shapes, so let me go back to something simple. Like I said, my middle point should be 5. So if I take the maximum number of shapes and I divide by 2, then I'm already in the middle. Now I also need to subtract the average size of the cube, which is a cube has a width of 1. So if I remove 0.5, I will also be in the center of the cube. So I can say, okay, I'm also removing 0.5. And now this number, this 4.5 number that I've just computed, needs to be subtracted to all the positions of my x. So I also need to put another subtract here and removing this number from my index, which is counting here. And now I'm replacing my x value by this. Check it out. So now I'm saving the batch. Let's see. If I change the number of repeats, I expect that my shape is always drawn in the center. As I said before, completely procedural. So that's pretty cool, I think. I think it's already a good overview of what we can do with arrays, comp array, and the difference between them and just the regular array operations that I tried to show at the beginning. How we can also start to animate shape, change their position, their scale, their rotation as well. Why not? We could say, hey, here, I'm going to create another array for the rotation. And the rotation here would be in degrees. So the rotation would be maybe minus 90 to 90 degrees. And then for this one to, I don't know, 45 to 200, whatever. And the same here, 0 to 180. And I know it's an array 3 that I need. So I'm connecting this here to rotation. So now you see all the cubes are also individually rotated. So I hope you see the potential with this. We're just using this rotation scale colors and repeating a single shape, because we alter each individual instance on the GPU. You can create really cool effects, and just by having a simple timer, I already start to animate all the values. So that's really the bread and butter of Cables. You would use this all the time. And in the future lesson, we will continue with working with arrays, comp arrays, especially when you have data and you need to transform it, manipulate it. Keep in mind that comp array works the same with objects. If you want to alter some of the properties, add to them, it's really exactly the same. So yeah, this was I think a really important lesson. The mesh instancer is really paramount for Cables, and yeah, I really hope you're gonna practice a bit with this. So keep in mind playing with the stride, remembering how we array pack, but like using the comp to really alter each individual value. Now try maybe as an exercise to put squares into a circle, so that instead of being just like a wavy pattern, they could be in a circle. Then it could be a circle and a wavy pattern all together. You could create any shape you want. Keep in mind that this is really similar to how you would approach programming, and it's almost exactly like line by line of code that really are almost exactly what we do here with the ops. If you knew exactly what pattern you want to create, of course it would be faster to do it with code, and we will see that when we touch the code part. But I mean, if you code everything, why use Cables, right? Like the point of using Cables is to be able to quickly iterate, test ID, being surprised by parameters that are too big, too small, that you didn't really expect, but by playing with them, you created interesting, cool visuals. So I would say for the moment, don't pre-optimize things, right? As I said before, only make things that are obvious, and then you know them, you do them. Otherwise, you need to wait till you have your final design, and then you start to drill down on performance here. So how would you manage that? Is you would disconnect Cables to see which one are taking the most resources, and see if you can change things. And in most cases, it's because we are repeating things too much. So if you know that the values are not going to change, then why are you recreating the array values every time, every frame, right? Put the trigger once to limit this. So in our case here, the timer forces us to do this. But if I remove the timer, I don't need to redraw now all my X, Y, Z position all the time. I can simply put the trigger once before, and now it drops down. I mean, it was already few, but to absolutely nothing almost, because I don't need to regenerate the values, right? So hope you like this lesson, and I'll see you in the next one.